Congratulations to the AIG for organising the MEGWA Talk series, which is an excellent forum for local geoscience exchange. I'd also like to remind members of the audience that considering participating in the AIG Mentor Program, that the closing date for registration as a mentor or mentee is at the end of this month, and the program will commence in late April or early May. The title of my talk is deliberately controversial, and hence the reason why the statement ends in a question mark. When asked to present last year, I decided to set myself a stretch target in order to truly assess the quality of the Jaguar deposit. Let's see if it rates at the end of the talk. Another reminder, if you haven't had a chance to look at some of the Jaguar mineralization, Roger has kindly brought along a large piece of PQ core which sits on the table here, and a couple of pieces of fresh ore from a very shallow trench that was excavated recently, and it'd be worthwhile looking at it. This view on the title slide shows a panorama looking from Jaguar, looking north towards the Onça Rosa deposit. This is the obligatory disclaimer, which suggests if you don't make investment decisions purely on what I'm about to tell you, and if you have any doubts, you should ask either Roger or Laurie, who are both sitting here in the audience. Okay, I plan to cover a lot of ground in this talk, beginning with the location, discovery history, and then the regional and local geology, geochronology. At the deposit scale, I will delve briefly into the structural controls before explaining the mineralogy and alteration with reference to the lithogeochemistry, before addressing the resources and the important role of geophysics in the definition of targets at depths. I'll present metal endowment on both the Australian and world scale, before some preliminary comments on the evolving mineralization model, finishing with brief comments on the project timeline. Science involves the evolution of ideas, and all of the ideas are necessarily based on the shoulders of those who come before us, and I'd be remiss not to acknowledge that. In the case of Jaguar, the deposit was discovered by Valley in 2010, and our current understanding has been facilitated by the excellent archive of data and drill core available. We're also fortunate to have the involvement of Professor César Ferreira Filho, an expert in Brazilian mafic ultramafic systems. César has a long involvement with the Carajás region through several Master of Science theses. He is also involved in our current Centaurus Industry Academia Research Program via ADIMBI, which is the Brazilian equivalent of AMIRA. And that research study is called Understanding the Controls and Processes Associated with the Origin of the Hydrothermal Jaguar Nickel Deposit. Special thanks are also due to our commercial partners, Vector in terms of structural geology, MODA, mineralogy, SGC, geophysics, the University of Adelaide Geology Department, the Geology, Minix Consulting, and Mapability. However, the bulk of the hard yards are done by a very dedicated team on site, led by the exploration manager, Gaudius Montresor. The Carajás Mineral Province is truly a giant. Elephant country doesn't get much better than this. This map shows the best of the mineral endowment within a rectangle measuring 220 kilometres east-west by 130 kilometres north-south, centred on the town of Parauapebas. Many of the deposits are giants in their class. I've coloured the deposits according to their dominant commodities, and it is clear that as well as being the world's premier iron ore location, it also hosts the highest density of IOCG deposits on Earth, as well as several nickel laterites and the famous Serra Pelada gold deposit. What is missing is the plethora of not so well endowed and very, very small deposits of these four types, as well as gold-only PGE and manganese deposits. So you get an idea of the flavour of this part of the world. The satellite image on the left-hand side shows the location of Jaguar Project 30 kilometres north of the Centaurus base in the town of Tucumã, and 15 kilometres northwest of a major power substation at the Valley Onça Puma ferro nickel plant, with this power coming from the hydroelectricity generated on the Araguaia River. If you look on the image at the side, if you look on the image to the side here, see that this is the Puma nickel deposit, nickel laterite. This is Onça. This is the plant for both of these, and this range that looks like a bow here, exactly that. It's called the Serra Arqueada, which in Portuguese means bow, and that's a big hill topped with iron formation. In Brazil, there is a saying that everyone wants to be the father of a beautiful child, but an ugly child remains fatherless. And credit for the Jaguar discovery is very, very similar. I spoke to both the ex-Valley exploration manager and chief geochemist to elucidate discovery history, but their accounts were different. So I asked another ex-Valley geologist who was involved in the field team at the time, and his account permitted me to incorporate the salient points from each of the others, and to add the importance of persistence and serendipity, which neither had divulged. The initial focus was copper, ISU type copper, but was redirected to nickel as the exploration evolved. The path to discovery is often long, and along the way needs dynamic revision to avoid false trails and extra costs, and even premature tenement relinquishment. Empirical data needs to be understood for what it is and not downgraded if it doesn't fit the model. This slide shows the regional geological setting of the Carajás Mineral Province. The left-hand side image shows that Jaguar, whoops, sorry, hit the wrong button all the time. Left-hand side image shows that Jaguar is located in the central north portion of South America on the eastern margin of the joint Amazon and Guyana shield. The main image reveals 5 tectonostratigraphic domains. The Mesoarchean Rio Maria granite greenstone domain lies to the south of and forms the basement for the Neo-Archean Carajás domain, which is considered to represent an early rift architecture. North of the Carajás domain lies the Paleoproterozoic Bacajá domain. To the west lies the Paleo to Mesoproterozoic Guatemala-Felsic large igneous province, and to the east, the earlier domains are overlain by the Neoproterozoic Araguaia fold belt. So you're already getting the feeling that Carajás is hemmed right in and between everything of many different ages. That's very important to the whole developing story. In the Carajás Mineral Province, the northern IOCG belt, shown as the blue dotted line at the top here, is located on and astride the Itacahunas shear zone, whilst the southern IOCG belt sits on the Canaan fault. Both the Jaguar and a smaller nickel deposit called GT34, which is shown here in this magenta star just here, are located within the Canaan fault zone. The 2.72 GA GT34 deposit comprises pentlandite, pyrrhotite, apatite breccias hosted by scapolite, orthopyroxene, and hornblende plagioclase clinopyroxene assemblages. The details in this slide will be impossible to see, but I've chosen it to illustrate the geochronological knowledge existent in 2020 when Eliza Trumfull completed her PhD here in Perth at UWA. The x-axis shows the ages in geons with a series of IOCG and copper gold deposits arranged on the y-axis from north to south. Mineralization events are shown by orange vertical bars and tectonic or magmatic events by blue vertical bars. The age of the southern IOCG belt is outlined in red and the GT34 nickel sulfide deposit in magenta. Eliza commented that the uranium-lead Concordia age of 2.72 GA from GT34 came from metasomatized zircons and cautioned that fluid-induced processes can result in mixed age with no geological meaning. Note the many mineralization and tectonical magmatic events that post-date the formation of the southern IOCG belt that are listed in the lower right-hand side of the diagram here. Dominantly sinistral transgression, followed at the very end by dextral transtension associated with this Guatemala event, which is the last bar on the chart in here. This slide shows simplified geology of the area surrounding the Jaguar project. The basement rocks are represented by gneisses of the Mesoarchean Xingu and Carapana complexes in tones of pink. Well, kind of pink, salmon. These rocks are intruded by the dark blue Neoproterozoic layered mafic ultramafic complexes of Onça to the south and Puma to the north, and they are host to the nickel laterites that are being mined by Valley. And the orange plaqué granite at the bottom. And all of these units are contemporaneous with the deposition of the green Itacahunas supergroup at approximately 2.76 GA in an interpreted intercontinental rift environment, possibly in response to Manta Plume impact. The Carajás Formation, host to the Valley supergiant iron mines, was deposited at this time, and dating of dacite interbedded with BIF at Serra Arqueada in brown and shown with a yellow star on the map, implies the BIF to be a chronostratigraphic equivalent of the Carajás Formation. We interpret this interbedded dacite and those hosting Jaguar to be part of the same event. The deposit is cut by several unaltered Nick north-south dolerite dikes, which are interpreted to have been placed during the Guatemala Large Igneous Province at circa 1.88 GA by analogy with dikes documented elsewhere in the Carajás Mineral Province. If geochronology is a black art, then geochronology of sulfides within shear zones is darker still, and I don't claim to have any expertise in that subject. This slide shows the results of the initial local geochronology which we have had done. Geochronology is one of the items that is being addressed by the Adimbi Research Project, but we don't have any results to show you at the present time. However, after watching a webinar on the use of in situ laser ablation ICP-MS rubidium strontium analyses in biotite and chlorite, I sent some offcuts from gangue minerals, that is actinolite, apatite, biotite, chlorite, to Dr. Alan Collins at the University of Adelaide to see what geochronology was possible. The results revealed apatite uranium lead wasn't that successful at constraining absolute time of growth. Hence, it is quite possible that the data record an earlier apatite growth. What is clear is the extensive biotite growth or resetting between 2.0 GA and 1.95 GA, which may represent the peak of hydrothermal activity, which appears to be coeval with the latest foliation formation. There may well be two events in that interval, and possibly a third with the 1.85 GA sample coeval with the Guatemala Large Igneous Province. The local geology of the Jaguar Project comprises essentially 5 lithologies. Basement gneiss and granite, undifferentiated, is shown in pink. The Puma ultramafic complex at the top of the slide in green. Subvolcanic porphyritic dacite, or SVAP in the local language, in the local coding, SVAP, is shown in orange. Altered mafic intrusus, dolerite in pale blue, are all cut by younger, non-altered gabbro-dolerite dikes in dark blue. Main faults are commonly enveloped by alteration zones and can contain magnetotites and slivers of ultramafic. Jaguar and Leon lie on a southern strand of the Canaan fault, whilst Onça Preta and Onça Rosa lie on a northern strand. The Tigre deposit has an identical geological setting to Jaguar, but is oriented east-northeast following the McCandless fault. When Centaurus acquired the project in 2019, we also acquired the Valley Lithological logging codes, which are hierarchical, using a root lithology preceded by compositional qualifiers. It quickly became apparent during our initial July 2019 visit that the host rocks are highly altered with many varieties of hydrothermalites listed as shown. Brazilians use the term hydrothermalite to loosely describe banded quartz magnetite ironstones overprinted by a variety of alteration minerals and mineralization, as shown in the quote from Zara Lindenmeyer referring to the Gamaleira deposit in the northern IOCG belt. And this term, hydrothermalites, is equivalent to the term metasomatites in early Geoscience Australia records. Also equivalent to ironstones, we would normally call them. Hierarchical logging is very subjective in such ordered rocks. One person's chlorite, biotite, magnetite hydrothermalite is another person's biotite, magnetite, chlorite hydrothermalite. So we opted to maintain the logging system, but to use the multi-element analytical data to generate meaningful lithogeochemical groups to aid structural interpretation and resource estimation. The principal gangue minerals in decreasing order are magnetite, quartz, biotite, chlorite, actinolite, albite, apatite, talc, and tigerite carbonates, with minor orthoclase and allanite. The principal lithologies grade from grey-white to grey-green to dark green to green-black to black, and contacts vary from sharp to gradational. Note that the unaltered dacite porphyry, the second on the left-hand side, and the youngest diabase, DIA, are the only units with preserved igneous textures, all the others showing varying degrees of foliation and alteration. This slide shows typical mineralization styles, and it's a series of images including a series of images of non-deformed dacite SVAP against massive sulfide at the bottom. This one, oops, sorry again. This one in here, and also a myelinized SVAP on the right-hand side. The magnetite samples on the right-hand side are characteristic of sulfides from Onça Preta and Onça Rosa and approach network textures characteristic of typical magmatic sulfide deposits, except in this case that the cumulus mineral, inverted commas, is magnetite, whilst all the other samples are from Jaguar itself. All the core is NQ size, so it's about 45 millimeters in diameter. The principal sulfides in decreasing order are pyrite, millerite, sphalerite, pentlandite, pyrrhotite, chalcopyrite, boulderite, and minor nickeliferous pyrite, veinsite, and alteration products of copper. I mentioned at the beginning of the talk that the main IOCG belts are controlled by the major Itacaúnas and Canaã shear zones, which are interpreted to represent reworked Mesoarchean faults, reactivated during the development of the Carajás Rift, and subsequently during basin inversion and thereafter. These are subvertical mantle tapping structures and explain the strong vertical continuity of the deposits they host. This slide shows cross-sections from Sulphide and Jaguar South at the same scale and reveals the anastomosing patterns and continuity of mineralization, which is visible in both section and plan view. The image on the right comes from a recent deep drill hole at Jaguar South with the location shown. What is shown here are 10 meters between 612 and 622 meters. And it certainly shows that mineralization has no signs at the moment of thinning. Preliminary estimates of the whole 20-meter interval, that is, say, another 3 trays after what's shown here, suggest that you're looking at an interval grade between 3 and 5% nickel. The message is clear. Jaguar is just getting started, and the target of 1 million tonnes contained nickel is within sight. This slide shows a 3D view of the main Jaguar ore bodies on the right-hand side and the plan view at 200 meters RL of the Jaguar group with local ore body names on the left-hand side. Note the Onça ore bodies, so the ones at the top, Onça Rosa and Onça Preta, are essentially planar, whilst the Jaguar ore bodies are curvy planar and constitute a classical shear zone, as you can see from the plan view in the bottom down here. Foliations are the overwhelming planar feature observed at Jaguar, with the mean orientation steeply dipping south and commonly occupied by both magnetite and sulfides. This fabric controls the ore resource shapes shown previously. Whilst the number of measurements on the stereograms appear large, it should be noted that only 26% of all core drilled by Centaurus is able to be oriented due to the strongly foliated nature of the rocks inhibiting successful core orientation. Initially, drill core structural data was collected using the reflex IQ logger device, but these data proved to be of dubious quality, with linear data not routinely acquired. So the procedure was replaced by the more robust ore node method first developed by Inco Valley and now marketed by Vector. Pleasingly, from a blank canvas when Centaurus acquired the project, linear measurements now comprise 9% of the data collected, increasing the confidence when targeting ore shoots. The top panel shows there are 3 to 4 dominant lineation clusters along the girdle representing the main foliation orientation, with 3 of those occupied by sulfides, and that's the one shown with the dollar sign. The bottom panel shows small fold axes plunge data, and these cluster around a pole of 66 towards 154, which does not lie on the main foliation orientation, implying the folded foliation predates the strong monolithic foliation. To assess the spatial variability and maximum variability of metallurgical beneficiation studies, 136 composite samples of quarter core averaging between 7.8 and 28 meters downhole length were crushed to minus 3.35 millimeters plus 1.17 millimeter chips at ALS here in Perth, with polished thin section grain mounts prepared by Adelaide Petrographic Laboratories in Adelaide, and the mounted grains logged by Gary MacArthur of Modo Microscopy in Tasmania. A subset of the samples was also submitted to McKnight Mineralogy in Victoria for quantitative XRD and scanning electron microscope analysis of all minerals containing nickel from an optical selection was undertaken by the Geology Department of the University of Tasmania. This slide shows the spatial location of these samples, and the red dashed line in the middle of here separates the samples that are hosted essentially by granite either side from those that are hosted by dacite or SVAP, to the south. And the black traced lines are just longitudinal separations of the varying targets into east, central, and west accordingly. The lenses, the arrangement of the samples in the next slide is shown from northwest to southeast, following the increasing numbered arrows. So we're going to see that there'll be a one section showing from 1, then 2, then 3 through 4, 5, and then 6 at the end. Okay, so this busy slide graphs the variation in mineralogy of the composites from northwest on the left-hand side to south to east on the right-hand side. Minerals are arranged from the dominant protolith mineral, albite, at the bottom, through various minerals to the ultimate alteration product, magnetite, at the top, and have been grouped according to like minerals, with a legend shown on the right-hand side. Above the solid red line at the top, up in here, are the sulfides, which range between an average total of 4.1 to 14.8%. Note the abundance of magnetite, talc, chlorite, and antigerite in the granite-hosted samples left of the red dashed line, with respect to those in the dacite or swap to the right of the line. Also note the abundance of pentlandite versus millerite in the same samples. To the right of the red dashed line, the samples become gradually less altered towards the east. The dominant mineral chemistry from a combination of laser ablation ICP-MS, quantitative XRD, and scanning electron microscopy studies is shown in the left margin. Nickel is common in talc, surprisingly enough, chloride, and less common in biotite, while zinc is common in actinolite, biotite, and chlorite. These geometallurgical studies have allowed us to include the variable non-sulfide nickel grade into our block model to facilitate mining and beneficiation. The multi-element assay data has been fundamental in distinguishing various lithogeochemical data groups and defining definition and aiding the definition of mineral resource domains, and permitted a much better understanding of alteration and structural history. A selection of 23 elements were transformed using the centered log ratio and then submitted to classical principal component analysis. The top 7 principal component analysis factors were then submitted to k-means cluster analysis, with K6 chosen as the most useful, what's shown on this slide here. Top left-hand plot shows clusters 1 and 3, green and red and blue respectively, being the biotite chloride altered dacite and the unaltered dacite. The bottom left-hand plot shows clusters 4 and 5, being the mafic and altered granite dolerite clusters, and the top right-hand plot shows mineralization, clusters 2, low grade, and clusters 6, high grade. I draw your attention to these very sharp boundaries here between unaltered rock and very altered rock, and between rocks that got a lot of altered and a lot of mafics in it, and rocks that got very few mafics in it. And I'll put it to you that it's possible that these rocks may in fact have been altered in this particular manner, whereby the rocks here shown are in the grey are the biotite alteration halos, and I've changed the cluster numbers here to respect to that there. The possibility is that all of this material here may have been, at Jaguar South, may have been translated 1.3 kilometres to the east during a series of sinistral faulting, and that this zone here might translate back and fit nicely on with that zone, which means that zone would fit nicely on with that zone there. Now, as is most things that are hypotheses, this hypothesis can be tested. So to assess that hypothesis, the lithological, geochemical, and petrological data were divided into 2 blocks either side of the postulated fault in leapfrog, with the southern data block manually translated 1.3 kilometres west-northwest as shown in the right-hand side isometric view, and the results are shown on the left-hand side. Because a simple XY translation was used rather than the interpreted smoothly varying curved planar fault surface, small windows representing gaps and overlays were inevitable, and these are shown, these are highlighted in here as little triangles in here. The top panel shows the restored protolith geometry, but I've excluded the SVAP, which is by far the largest lithology, for clarity. And the bottom panel shows the results for nickel greater than 2%, superimposed by logged alteration style. It suggests, once restored, that the Jaguar mineralization may have originally been a subvertical pipe of approximate diameter 1 kilometre, scored by apatite magnetite quartz and sulfides and surrounded by marginal zones of chlorite and biotite alteration along the Planar fault strand, with the sinistral movement occurring between 2.0 GA and 1.98 GA, as evidenced by biotite and chlorite resetting and intense foliation development in the geologic samples. It is also permissive that the alteration of pentlandite to millerite occurred at this time, and pyrrhotite to pyrite. The unaltered north-south dolerite dike permissively records the 1.85 Guatemala felsic igneous province. And note that the size of the postulated pipe, 1 kilometre, is similar to that documented at GT34. The results of lithogeochemistry are shown in this cartoon north-south vertical cross-section. A monazite zone is interpreted to have formed at the contact between basement granite on the right-hand side and the dacite, and was intruded by a nickel sulfide mineralized pipe. Intrusion caused progressive alteration of the host dacite from a distal potassium, magnesium, lithium, iron member to a proximal aluminium, barium, beryllium, lanthanum-rich iron poor member surrounding a central core that grades inwards from low nickel grade to high nickel grade. The nickel-bearing zones are enriched in calcium, iron, phosphorus, sulfur, and yttrium, reflecting magnetite, apatite, and sulfide, as well as a suite of base metals: silver, arsenic, bismuth, cadmium, cobalt, copper, lead, antimony, tungsten, and zinc. Subsequent sinistral faulting accentuated the structural juxtaposition of barren and high-grade zones within the monazite. The November 2022 mineral resource estimate reached a total of 108 million tonnes at 0.87% nickel for 938,500 tonnes of contained nickel. This represents a 56% increase on the 2010 value resource estimate within the 3 years since Centaurus has taken ownership. Importantly, plus 500,000 tonnes of nickel metal is located within 200 metres of surface, with a high-grade component of 28.6 million tonnes at 1.5% nickel, with 30% of this resource within 100 metres of surface. At present, drilling continues apace, with 6 diamond rigs and 1 RC rig on site. Now that we understand the mineralogy and structure of the deposit a bit better, we'll examine the geometry of the ore bodies and mineral resources. This slide shows an isometric view of the various ore lenses within the proposed open pits. The pit shells shown in black, or the ones that are shown there in grey, sorry, are those that were used in the preliminary scoping study, whereas the current planned Jaguar pit has the 2 Jaguar pits, that's these 2 here, this one and this one, coalescing into the one with a strike extent of plus 3 kilometres up to 1 kilometre wide and a depth that extend to over 300 metres. And that makes it equivalent in size to the Kalgoorlie super pit. The next slide will focus on cross-sections through the Jaguar South, 3 cross-sections through Jaguar South, Jaguar Central, and Onça Preta ore bodies, as shown here. We'll look here, here, and here. These are the cross-sections that I've just mentioned. Note the preference for the mineralization to develop around the dolerite dike, here at Onça Preta, whilst at Jaguar Central, the dolerite dike is interpreted as cutting and, in fact, truncating a mineralization. It is interpreted the competent anisotropic nature of the granite host at Onça Preta resulted in the more focused nature of the mineralization versus the wider anastomosing shear zone in incompetent altered dacite at Jaguar. Current drilling has concentrated on defining open pitable and shallow underground resources, and the depth extents have not been tested. This slide also shows in grey, it's a bit hard to see, perhaps back there, these grey lines here, through here, and over here are the downhole EM plates that were targeted, and they, as you can see, they're showing excellent correlation with the subsequent drilled sulfide intersections. The success rate of the downhole DHEM technique at Jaguar is the envy of many nickel sulfide deployers elsewhere that have to deal with false positives. At Jaguar, because the mineralization represents the only sulfides, and because there are no sedimentary sulfides, the hit rate's guaranteed. Centaurus has imported and operates its own downhole EM equipment with design and orientation supplied by geophysicists at SGC here in Perth. To date, 200 conductor plates have been generated from 130 drill holes. The first slide here just shows the drill holes that have been used as platforms and the plates interpreted at Jaguar. The Jaguar South and Onça Preta deposits are defined beyond 500 meters depth and remain open at depth and along strike. EM plates suggest a steep easterly plunge for both Jaguar South and Onça Preta, commensurate with the plunges from drill core. EM is the main driver of resource step-out, extensional and exploration drilling. As well as the defined resources, Centaurus is actively testing a series of other targets within the tenement shown in green in this slide. Note the soil geochemical anomaly defining Jaguar continues westward to Lyon and beyond, and has only received sparse drilling. Another enigmatic target is the Lithologies target here, which represents a very, very intense magnetic anomaly where values of plus 1 gram per ton PGEs have been intersected in drilling. The Jaguar deposit is currently the largest nickel sulfide resource held by an ASX-listed company other than BHP or Oz Minerals, shortly to become BHP, and one of only 3 companies with both open pit and underground resources. Curiously, when I first saw this graph, I noticed that the average grade, current grade at Jaguar is equivalent to the BHP Leinster operation, excluding Venus, where I cut my teeth in nickel exploration 42 years ago. I asked Richard Shoddy of Minix Consulting to make me some graphs to be able to assess the size of Jaguar on the world stage. This graph shows all the nickel sulfide deposits in Richard's database divided into high MGO, i.e. Commodity hosted, and low MGO, i.e. mafic intrusive hosted, and others, where the class is either not known or can't be classified on the basis of MGO content. Deposits containing greater than 1 million tonnes nickel metal are defined as giant or world-class deposits. And you can see that with successful additional drilling, Jaguar will soon join this exclusive club. Note also that many of the giants are actually camps comprised of several smaller deposits feeding a central mill. For example, Thompson Belt, Kambalda, Raglan, Sudbury, and Talnak. This graph shows a selection of the other grey dots from the previous slide, colour-coded according to age of nickel mineralisation. Those chosen are commonly regarded as being of hydrothermal origin. Note that the highest and lowest grade deposits, so down here Talvivara, and up here the South China deposits, have the highest and lowest grade deposits are commonly associated with zinc. The other deposits form a horizontal band between 0.75% nickel and 0.97% nickel, of which Jaguar is the largest. Enterprise is hosted in marine metasediments. Avebury and Janshaling forming the contact halos of granites intruding ophiolites. Beau Azar is hosted by shear zones and ophiolite, while Manali and Epoch are hosted by mafic or ultramafic rocks. The age of the Epoch shear-controlled mineralization is only estimated, but is hosted by the 2.7 GA Mashaba ultramafic suite. Jaguar is the only deposit hosted within the felsic rocks. The objective of this talk was to clarify whether Jaguar is the oldest and largest hydrothermal nickel deposit. Clearly, black shale deposits are the largest in terms of nickel tonnes. But should geochronology prove the age of the early apatite magnetite sulfide event at Jaguar to be Neo-Archean, then it will be the oldest. The origin of the Jaguar deposit is providing fertile opportunities, research opportunities for academic researchers and challenging previously held ideas regarding the value and exploration potential of hydrothermal systems. Shortly after the discovery of the Enterprise system hydrothermal nickel deposit in Zambia, Dr. Steve Beresford commented that the next nickel sulfide deposit would look nothing like those before it. I think the Jaguar certainly has proved him right. As to whether Jaguar is of magmatic or hydrothermal origin will ultimately be resolved academically. But the outcome is of great interest for nickel explorers, as it may open up new search bases in areas never previously considered as prospective. After all, who goes looking for nickel sulfides in dacite? Just as recent research in Chile suggests that the iron oxide apatite deposits are the root zones of a hydrothermal continuum that extends upwards into IOCG deposits, the current academic consensus is that Jaguar may represent a shallower nickel-rich version of the IOCG type deposits, with the GT34 deposit representing a deeper variant of the same mineralized system. The key control in Chile and Carajás, despite the difference in age and setting, appears to be that both regions lie in multiple reactivated mantle capping shear zones. The origin of Jaguar drew my attention as soon as Centaurus began due diligence in August 2019. I was aware of the possibility of spatial resolution of mineralization types afforded by the OSNARCA system developed and promoted by Dr. Carl Brauhart here in Perth, where the anagram OSNARCA refers to ore samples normalized to average crustal abundance. Carl's three-dimensional geochemical algorithms permit visualization and differentiation between a variety of hydrothermal and magnetic deposit types. Hydrothermal deposits form along what Carl terms his main hydrothermal plane, from sedimentary hosted deposits on the left-hand side across to igneous deposits on the right-hand side, and with the vertical dimension being the magmatic axis from granites down to ultramafics at the base of the diagram. Given the clear separation between layered intrusions, magmatic nickel copper iron deposits, nickel copper PGE deposits, and IOCG deposits at the bottom here, and this gap between the IOCG and the rest above that, I was very keen to have Carl assess Jaguar using the data, using this method. And I contacted him with the request to process the data from the only hole within the Valley database that had sufficient elements to be used. There's only one hole, is that case. As you can see, these limited results from one hole at Jaguar West in white show that Jaguar occupies a position uniting in IOCG and magmatic nickel iron, nickel copper PGE deposits in magmato-hydrothermal space. One published model. This slide depicts one of the published models for this type of deposit, and includes Jaguar from Garcia's 2018 Master of Science thesis. The Jaguar and GT34 deposits are shown hosted within the Canard Fault Corridor, which also hosts prominent southern IOCG belt deposits such as Sicarinia and Crystallinum. Fault Corridor marks the boundary between the southern Mesoarchean Rio Maria granite greenstone domain and the northern Neo-Archean Carajás Rift domain. This model adopts the classical IOCG alteration zonation, varying from calcic alteration at depth, here shown in green, through potassium iron magnetite alteration to potassium iron hematite alteration at shallower depths. And Jaguar is shown as occupying a shallow position associated with felsic magmatism. What is missing are the deeper portions of the Neo-Archean mafic ultramafic complexes through which the hydrothermal fluids passed to leach the nickel plus or minus sulfides. Research is continuing, and so watch this space. This slide shows a panoramic view looking south from the Pumalad complex towards Jaguar, the Serra Arqueada range in the background. This is a Jaguar ridge through here, Jaguar South, Jaguar North, Central, and Jaguar West. In the very background, that's capped by banded iron formation, Serra Arqueada. Our working hypothesis is that the Jaguar mineralization was emplaced as a vertical pipe within the Canard Fault during the southern IOCG belt event between 2.72 GA and 2.68 GA during or shortly after the Carajás Rift. All of the giant IOCG BIF and mafic ultramafic bodies within the Carajás Rift have Neo-Archean ages. The initial sulfide assemblage may have been similar to magmatic nickel deposits comprising pyrrhotite, pentlandite, pyrite, and chalcopyrite. Peak hydrothermal alteration at 1.9 to 2.0 GA associated with a 1.3 sinistral shear reactivation of the Canard Fault dislocated the Jaguar South ore body from the main pipe, which comprises Jaguar Central, Central North, and Jaguar North. This event would explain why the Jaguar mineralization is pyrite millerite rich compared to the Onça Rosa and Preta mineralization that were protected within granite, and may explain why our initial apatite uranium-lead geochronology wasn't that successful in constraining the absolute time of growth, and may represent instead just resetting. Minor geochronological resetting and late dike emplacement associated with the 1.85 Guatemala felsic large Jaguar Province completes the history. This slide shows the proposed pits and infrastructure. Flotation test work released today as an ASX release demonstrates that over 94% of sulfide recovery to concentrate, that's equivalent to total nickel recovery of 78% based on the average head grade of the current mineral resource estimate, with over 800 kilograms of high quality concentrate produced to feed the Jaguar pilot plant. Flotation results vary, however, depending on the source, with Onça Preta, Jaguar North, and Jaguar Central North being lower due to their higher zinc content. So production of a high purity, zinc hydroxide product is planned to benefit the project economics. Centaurus is currently completing a definitive feasibility study scheduled for release at the end of the fourth quarter this year, and the final investment decision has been scheduled for the third quarter 2024, with production targeted in 2026. In summary, the Jaguar nickel deposit differs from the majority of nickel sulfide deposits of hydrothermal origin, representing a hydrothermal style between magmatic nickel copper sulfide and IOCG mineralization. Mineralization is hosted within a myelinite zone developed in dacite at Jaguar and flanking a dolerite dike intrusive intertonalite at Onça Preta and Onça Rosa. Nickel mineralization is present as pentlandite and high tenor species such as millerite, violarite, and vasite. Copper and gold are only weakly anomalous, whereas zinc is highly anomalous. The host subvolcanic dacite porphyry at Jaguar shows the following successive lithogeochemical alteration assemblages approaching nickel mineralization. An outer zone, alteration zone where biotite and chlorite predominate, which is anomalous in potassium, lithium, magnesium, and iron. An internal alteration zone where biotite is predominant, anomalous in calcium, iron, phosphorus, nickel, calcium, iron, nickel, phosphorus, rare earths, and sulfur. And the mineralization there is mostly associated with magnetite, apatite, and sulfides. Jaguar has a mineral resource estimate of 108 million tonnes at 0.87% nickel for a current total nickel tonnage of 938,500 tonnes of contained nickel. And is interpreted the age of the deposit is Neo-Archean and that it suffered subsequent deformation and upgrading in the Paleoproterozoic. So, to conclude, I revisit the title question, which clearly needs revision. The Jaguar sulfide deposit is not the world's largest hydrothermal nickel deposit, but ongoing research may indeed reveal it to be the oldest. Thank you very much.